All right, so picking up right where we left off, we have our four different types of orbitals, S, P, D, and F. Okay, so except for the first four elements, every element has at least two types of orbitals, and they go in order of when you're going to see them, okay? So first four elements only have S orbitals, okay? And then you add in a P orbital. Eventually you're going to get down to where you add in a D orbital, and then finally you're going to get down to an F orbital. So, S orbitals. These orbitals have the least energy in every energy level. Now, when I talk about energy levels, periodic table is actually wonderful in the way that it works. It's that each row is its own energy level, okay? Now, there is some kind of funky stuff that happens when you add in the D and the F orbitals, but we'll get to that later, okay? So, each energy level, so we've got hydrogen and helium in our first energy level, so they have orbitals that are known as S1 orbitals, or 1s orbitals, okay? And then you go down to your next, I think it's lithium, okay? That's when you add in the 2s orbital. And then you start adding in the 2p and so on and so forth. And we'll get into that order in, I believe it's 5.4, okay? So S orbitals only have one possible orientation, and it's pretty easy. It's because they are spherical. Okay, so this is what they look like. And when I say orientation, possible orientation, this is talking about 3D orientation around an origin. Okay, so we have our X, Y, and Z, axes. Okay, so the Z just means that it's in 3D. Okay. So X and Y are used to, and then Z is just perpendicular to both of them, okay? So each S orbital only holds up to 2 electrons. This is where it's going to get kind of important that you recognize the orientations, okay? Because each orientation has its own set of orbitals, basically, okay, contained within. I'm not explaining that very well. It'll make more sense when we get to some of the other orbital shapes. Okay, so S orbital can only hold up to 2 electrons. So 2 of your 8 valence electrons will be found in this orbital. Okay. All right, moving along, we have our p orbitals. So p orbitals have the second least amount of energy in each energy level. Okay, so electrons will first go into the s orbital, and then if there are more electrons, they will go into the p orbitals because it contains more energy. There are 3 possible orientations. Each orientation can hold up to 2 electrons. So a p orbital can hold 6 total electrons. P orbitals are what are known as dumbbell shaped. Okay, so might be a little bit familiar. And when I say there are 3 possible orientations, you're going to have one that lays out on the z-axis, one that lays out on the x-axis, and one that lays out on the y-axis. Okay. Again, each orientation holds up to 2 electrons, so there are 6 total. And remember, these orbitals are just regions of probability, so it's most likely that you're going to find these electrons in this kind of path, okay, somewhere in there. So the other 6 of your valence electrons will be found in these orbitals, okay. All right, then we get up to D and F orbitals. So these have the highest energy out of all 4 different types of orbitals. They are really kind of funky. Okay, so your d orbitals have 5 different orientations and can hold up to 10 total electrons. Again, they look real funky. Okay, so don't worry too much about the shapes for these, especially not because you've got that one with the donut around it. Yeah, this is more for your information, just to kind of look at and see, wow, that's really weird. I'm glad I didn't have to do the math to figure those out. Then you've got F orbitals. So if you think D orbitals are funky, Wait until you see these. There are 7 different orientations for your f orbitals, and they can hold up to 14 electrons each. There you go. They look like Easter eggs. You'll also notice that they don't always come together at a single point. In fact, they usually don't. So it's kind of weird thinking that the electron can be in any point in those orbitals, okay? So, but they're not going to be found in between the orbitals. Yeah, that's a weird concept to think about. But you also see that you have a double donut there on the right. Like I said, f orbitals get real funky. And again, don't worry about knowing shapes or anything like that of these. This is more for your information. Just take a look at it kind of thing. Okay? All right. So again, like I said, the periodic table is arranged beautifully with these with these different types of orbitals. You have what's known as the S block, which is the first 2 columns on the left. You have the P block, which is the last 6 columns on the right. Then you have the D block, which is the transition metals. And then the F block, which is the 2 rows that are down at the bottom. Okay? Fun little thing. If you ever forget how many electrons can be in each orbital, all you have to do is remember this. Okay? So S orbital, we know that it holds 2 electrons tops. Look at that. 1, 2 columns. Okay. P orbitals, we know that they can hold up to 6. 1, 2, 3, 4, 5, 6 columns. Okay. D orbitals hold up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. It's working pretty well here. F orbitals can hold up to 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 columns. There you go. Okay. F orbitals can be a little bit funky sometimes because there are the lanthanum and actinium that are sometimes put right here. Those are d orbital atoms. Okay, they belong right here in the D block, right? But sometimes they just get put down here so that they can say, hey, go to this spot here and then go across. Okay, so just be careful of that. Those 2, actinium and lanthanum, are Ds, not Fs. All right, so with your orbitals, you can read the periodic table from left to right, just like this, okay? So first up, you've got 1s, and then you go down here, you've got 2s, then across to 2p, 3s, across to 3p, 4s, then you go to 3d, and 4p, 5s, 4d, 5p, so on and so forth. Now when you get down here, you have to remember that the F's go right here. So you get 6s, 5d, 4f, 6p. Okay. So the smallest energy level for each orbital type is 1s, 2p, 3d, or 4f. Okay, so what you'll notice on the periodic table that we just looked at here, there is no 1p orbital. Okay, it starts with 2. There is no 2d or 1d orbital. It starts with 3. And then with the f's, there's no 1f, 2f, or 3f. Okay, that one starts with 4. Now I just remember because s is your first orbital, so it can start at 1. P is your second orbital, so it can start at 2. D is your third orbital, so it'll start at 3. And F is your fourth, so it'll start at 4. Okay, now another nice thing about this system is that it is designed to expand as we fill in more of the periodic table. Okay, so if we get more rows, okay, you just add in another energy level. Okay, so it would be 8s, 9s, 10s, so on and so forth. And you can do that with each of these different blocks. So theoretically, there is a 6f. We just haven't found it yet. Okay? All right, So that is it for this section.